Now let us see a more accurate device, screw gauge. We know about meter scale. Meter scale has a least count 0.1 centimeter. Vernier calipers gives you a least count of 0.01 centimeter. But this can give you one more digit, means 0.001 centimeter or 0.01 millimeter. So it gives you more accurate reading. Now let us see the device. This is screw gauge. It has two scales. See, this end is a milled head. I can rotate it this way. Now you can find one scale here. It is called pitch scale. Pitch scale 0, 1 millimeter, 2 millimeter, 3 millimeter, 5, 10, this way readings are noted. You can see a horizontal line there. Then next scale is here. This scale is called head scale, and you can see values from 0. So starting value is 0. So total 100 divisions are there. So this scale is called head scale. Thus there are two scales, pitch scale and head scale. Then I can rotate this way. Then see, when I rotate this way, you can see the screw coming up and one tick sound is heard. Now the horizontal line of pitch scale is visible now. One end is visible now. Then if the 0 of head scale is coinciding with that, there is no error for the device. But normally it won't be coinciding, so there will be error. In this case, the 0 is above that line. Sometimes it may be down. For this apparatus, it is above that line. Here, the 0 of head scale is 7 divisions over that line. So 0 correction is plus 7. 0 correction is plus 7. So I shall note it. 0 correction is plus 7. So if it is down that line, suppose it is 7 divisions down this line, then 0 correction is minus 7. So if this 0 is above this line, 0 correction is positive. If 0 is down this line, 0 correction is negative. Then I am calculating the least count. So before that, let me calculate the pitch of this screw. Pitch can be calculated by using this equation. Pitch is equal to distance moved divided by the number of rotations. Here, so I am rotating, tick sound is heard, I am loosening it. So, 1 rotation completed, 2 rotations completed, 3 rotations, 4 and 5 rotations completed. Now, the 5, 0, 1, 2, 3, 4, 5. Up to 5 is visible. So, distance moved is 5 millimeter. Distance moved is 5 millimeter. And number of rotations is 5. So, I get the answer as 1 millimeter. So, 1 millimeter is the pitch of this screw. Then, least count is equal to pitch divided by a number of divisions on head scale. Here pitch is 1 millimeter divided by, there are 100 divisions on this head scale. So that divided by 100, I get the answer as 0.01 millimeter or 0.001 centimeter. So the least count of this device is 0.001 centimeter. Next, I am calculating a diameter of a wire using this device. So this is our wire. I want to calculate the diameter of this. So for that, see, in between the gap, here in this gap I am placing the wire. Then tick sound is heard. Then I am seeing here, see, only the first line is visible to me, the zeroth line is visible to me from pitch scale. So the pitch scale reading is 0. Then next is the 36 of head scale is coinciding with the horizontal line of pitch scale. 36 is coinciding with horizontal line of pitch scale. So observed value of HSR is head scale reading is 36. Then corrected HSR. I want corrected HSR. Corrected HSR is observed HSR 36 plus 0 correction 7. So 36 plus 7 is 43. So observed HSR 36, corrected HSR 43. Then diameter of wire is equal to PSR plus corrected HSR into LC. PSR plus corrected HSR into LC. PSR is 0 plus corrected HSR is 43. 43 into 0.01 is 0.43. So I get the answer as 0.43 millimeter. So I am getting the answer in millimeter. So I can take 5 trials. So PSR will be always same, but this may be slightly varying. Sometimes you may get this also same. So anyway, you take 5 trials and take the average value of diameter. Then you take the half of that value. You will get the answer in millimeter. Then you convert the same to meter. Then length of the wire. Length of the wire can be calculated this way. So using a meter scale, you can calculate the length of the wire. So the length is here 28.5 centimeter. So length of the wire is noted. Length of the wire is 28.5 centimeter. Then you can convert it to meter. Then volume of this wire is equal to, this wire is assumed as a cylinder, so volume is equal to pi r square L. Radius you calculated, diameter you found, half of that is radius, length you know, so substitute the values, you will get the answer in meter cube. So that's all about the volume. Now this is a glass plate. It has irregular shape. Then this is the shape of a prism. So base has irregular shape, up to the top it has the same shape. So I assume that this is a prism having irregular base. Then you know the general equation to calculate the volume of this. Volume is equal to base area into height. So height is thickness. So thickness can be found by using our screw gauge. You can place your glass plate between the studs here. See, tick sound is heard. So I am noting the value. See, 0, 1, 2, 3. So 3 is found. So the pitch scale reading is 3. Then 87. Not 87. 77. 77 is the observed HSR. So 77 plus 7, it is 84. Then I am substituting in this equation. So thickness is equal to, same equation I can use. Thickness is equal to PSR plus corrected HSR into LC. So I can answer as 3 plus 84 into LC. So 0.84. Answer is 3.84 millimeter. This is the thickness of this glass plate. Then you can place this glass plate carefully over a graph paper and mark its boundary, and you count the number of squares there. It will be the area of this glass plate. So you can see a picture there. So a glass plate is there, it is a boundary. You calculate, you count how many squares are there. So this is one square, small square. Its one side is 1 mm, so its area is 1 millimeter square. So how many millimeter square? You calculate the area, then you multiply that area by thickness. So it will be the oleum. So oleum is equal to base area into thickness. So base area you calculated from the graph, that much millimeter square. You convert the answer to meter square. That into thickness you got here. So this also you convert to meter and substitute here. You will get the oleum of this glass plate. Hope you understood. Thank you.